all enjoy an exchange and learn a little bit more in the process. So the Westley Group, as Arthur's already alluded, has got a long history of its own. The connection between us and Whitechapel Bell Foundry actually goes back a very long way, in that when I was at university in London in the early 1970s, I was taken to Whitechapel Bell Foundry as an example of a working foundry in London at that time. I was at Imperial College. So I've sort of feel connected to it and understand it going back all those years. But recent history is that Alan Hughes, who some of you may know, who owns Whitechapel, is a fellow liveryman with me in the Worshipful Company of Founders. And so we're friends. And when we discovered that Alan was planning to close the operations in central London, we worked closely with him in order to keep the Whitechapel traditions and bells and designs going forward. And that's exactly what we've done since they cast their last bell, which I think was 2017, about then. So talking about our own history, just so people who don't know us from Adam can have a bit of an understanding, we actually have been involved in doing things with copper-based alloys since the 1700s. One of my forebears was involved in the construction of St. Philip's Cathedral in central Birmingham. And it was his son, who was also called William, who made the very first street map in Birmingham in 1731. Map, a sales job on his part to try and promote Birmingham as a growing place. Well, it wasn't yet then a city, but as a growing place that people could come and invest in and move to, and was prospering greatly. And he was sponsored to make this map, because he was a cartographer. He was sponsored to make this map by the local MPs who wanted to help him promote the area. And what we believe is that he, in order to create these maps and then print them and publish them, he needed to make his copper and brass plates that he then engraved to actually create the map. So we think that's when it all started. And obviously there was bronze and brass things going on in Birmingham, but that's our beginning involvement, was around this time, which is actually the 1700s. And his map 1731, as I say, is recognized as being the first ever street map of Birmingham. So what happened subsequent to that was we really started a proper bronze foundry, so to speak, that was on an industrial scale in 1800. And that was set up in Dudley in the West Midlands. And it was set up to support the operations of the then Earl of Dudley, whose ironworks were very substantial. They became the Round Oak Steelworks in Brierley Hill and Dudley. And it was in order to help him to be able to make that thing that we were making the bearings which were used in the rolling mills and the production of iron and, well, it wasn't steel then, it was iron then. And that's what caused us to make the step of building a really half decent sized foundry to support these growing iron activities. So this went on largely all the way through the Victorian times. And of course, the railways were a marvelous opportunity for us, because all the bogies and rolling stock had bronze bearings on them too. So we really lived happily off just making bearings for railways and steel mills and all those sort of metal processing equipment, mechanical presses, and all the equipment that was needed right through and during the Second World War and beyond. So it was only since then, in the 1980s, that Westley Group began to expand by trying to become more dominant in our industry, which is to say remain utterly focused on copper-based alloys and see what we could do to consolidate that industry beyond our own very parochial patch in the West Midlands. And the first acquisition was actually in 1982 when we bought Williams Alexander Foundry, which was a Cardiff-based company supporting all the steel industry that was going on in South Wales, and was very like into our business. Saying on the slide, one of the largest copper-based foundry groups in Europe. So our competitors today tend to be European or American rather than in the UK particularly. So right, this is just in the corner here to give you a feel for how our industry was profoundly changed in the 1980s. You could say post Mrs. Thatcher. A lot of these foundries, I've listed them all in the corner there. There's 33 have been consolidated into Westley Group. We didn't necessarily buy them all, we bought some, but a lot of shipyards used to operate their own foundries for their own purposes, like Swan Hunter and Vosper Thornycroft and Rosyth and Yarrow Shipbuilders. Similarly, a lot of the steel works had their own tied foundries, as they described them. And also people like David Brown had the foundry to support their gear activities and whatever else. But bit by bit, we endeavored to take on the activities of those foundries, do it on a larger scale under one set of overheads, and give benefit to the customers of a more profound and more diverse service, taking full advantage of all the technologies that we brought to it. So today, as it says here, we're about 300 employees, and we actually operate from 4 sites today. And the reason for that is because each site represents a process, and the skills and the people that we need to do different activities are very particular for the process. So the original site, which is our Cradley Heath site today, exclusively makes centrifugal cast product. So you can see the sorts of things in some of these pictures. One of the biggest outlets for these sort of products, which are, if people that don't know, centrifugal casting, you pour molten metal into a rotating steel mold, and you can only make cylindrical shapes. But the process itself, because of centrifugal forces, can give extreme pressures while the metal is solidifying. So you get the quality of a forging out of a casting, because the extreme gravitational forces squeezes the metal against the edge and gives an excellent product. And so typical examples here are ships' bearings. And we probably export, I don't know, 60–70% of what we make here to merchant ships around the world, even for the US Navy and Coast Guard and other people who are using these types of components. Safety critical stuff as well for nuclear power industry, and column pipes and these rising mains. These are all to do with the oil industry for extracting oil from offshore platforms and for firefighting systems that are associated with that. And then down to some quite small and sophisticated bits that go into Rolls-Royce aero engines. They're the bearings and the seals that fit in the aero engine. So then the other site, which was called JT Price, this is up at Newcastle under Lyme, close to Stoke. This has always focused on sand casting, and this is our centre of excellence for sand casting, and it's actually this site that casts the bells. But we make all sorts of shapes there, pumps, valves, you can see from the pictures, and even parts for body scanners, and it's quite diverse. But each of the sites, by the way, employ around 100 people. So other products that JT Price site makes at Newcastle under Lyme is associated with artwork, and I think the bell production is probably quite closely aligned with what we do in the art world, but also increasingly as part of buildings, like facades for buildings. With our desire to become more and more green, prestigious buildings now are built with a facade that will sort of basically be zero maintenance and not deteriorate. And the classic example of this, which is the slides on the top of the page here, is Portcullis House, which is the new extension to the Palace of Westminster for the MP's offices. And the entire external structure of that building is made of stone, which are the columns going up, and bronze. So it has got a design life of 1,000 years, which was the architect's brief. And it was a marvelous project to be involved with, but that's what we did. And then at the bottom of the page, we've got work we do here with Damien Hirst, for an example, where we're making very large sculptures. We tend not to be involved in lost wax on the smaller sizes. It's when they become very large pieces that we get engaged, and we use digital technologies these days to encapsulate the shape and create the patterns and then the castings and so on. So the other site we have in Stoke is totally geared for defence, and this is really for the submarine programme. So we're making bits currently for the new Dreadnought Trident follow-on, and we're making for Astute. And the company Mies, which was started by the Mies family, are now sadly no longer with us, but the business we bought, and they started right at the beginning of the Polaris program. So you can say we've been supporting the Navy on the nuclear side since day one, pretty much. So the other site, the last site, is up in West Yorkshire, Cleckheaton, and this is focused on die castings for the firefighting equipment. So that's what we do there. And if you look at the modern fire engine, the bits of kit on the back and the things that stand up in the street, all those connection parts, many of them are made by us as a product that meets all the British and international standards for firefighting. That's a company called Walter Frank. So, having given that bit of ground to what Westley Group does, which is quite diverse, we'll move on to bell casting, because bell casting was something which we'd not really indulged ourselves with. We had made a few bells for, I think, locomotives and ships, which were literally one-off pieces, but they certainly weren't tuned proper bells, if I could say that. And so the engagement with Whitechapel has been an education for me, as well as all our people, to see and begin to understand what is necessary and how bells have evolved and all of it. And I must say, I've found it extremely interesting. The thing which surely fascinates everyone as well is the ancient history of Bell Foundry. I mean, we go back thousands of years of things, and experiments to see what works best and how best to do it have been going on really throughout the entire period. The outcomes, however, were often quite variable, which without science and technology at its highest levels, it was a bit of a challenge to make a bell and be absolutely confident that it was going to be perfectly okay. But of course, as with everything in human life, it's about the people, and the experienced foundries that were good and competent succeeded, and those that failed often failed. So in the end, so it's been interesting to learn about the more successful ones and how it's evolved. And so from our perspective, we have stuck with the notion of just trying to make the very best bell as a casting, and we'll come on to that in a minute. So Whitechapel Bells has got probably the most illustrious history of any bell making company. You all know, without me telling you, I'm sure, that they made the Liberty Bell and the Big Ben bell, that is, well, Ben itself, that is bell, and of course they were established way back in the 1500s. So, as I was saying, the casting process is a challenge. Engineering activities, one of the few things, the actual casting process where you begin the pour is unique, because everything has to be correct every day in a few seconds where you're actually doing the pour. And things that have to be right are the temperature of the metal must be right, the metal composition must be precisely right, the gas content of the metal must be as little as possible, the mold preparation has to be right, and indeed the pouring technique, how you get the metal from the ladle into the mold, has become more and more of an engineering challenge to do that in a manner that makes the flow of the metal as quiescent, as gentle as it can be, in order to protect the quality of the metal stream. And all this needs to be optimized at the same moment for the few minutes, seconds when the pour actually takes place. So there's our challenge. So Westley Group's philosophy towards bell founding is that we recognize our forte, as I was saying earlier, we know an awful lot about copper-based alloys, but it's principally about making up what I would describe as a high integrity engineering casting. That's to say, we want it as defect-free as is humanly possible. And the real opportunity with Whitechapel, given their fantastic portfolio of shapes and sizes and back catalogue of things we've done, was to take those dimensions and shapes and let's see what we could do to promote the brand, develop the brand, and make the most excellent castings that we can to see if we can make something better than's ever been made before. That's our philosophy, and that's what we're trying to achieve. So design and the shape, obviously very important, and we work with people, not least Nigel Taylor and others, to make sure we try and get these designs and shapes and things as authentic and correct as we possibly can. We do use a different technique to the traditional way of producing a mold for a bell, was to strickle it. We call strickle it. You shape it with a moving from a central axis to create the shape in a loam sand, which is sort of what we call green sand with manure and things in it to bind it. But that's all very Victorian and quite difficult and very time consuming. So we go through a different route to create the mold using modern materials and techniques. And that is what we've done to make sure we can build the best product that we can. So the decorations and dedications are all, as we know, bespoke, and it can be, quite challenging to get them exactly right. But again, we've learned, and we've started from a zero base in the beginning, and we've now, which we've come on to, made a lot of bells for a lot of people, and we've got, if I dare say, quite a bit better at getting things exactly and precisely as they should be from that perspective. But as we were saying before, it's all about making the most dense and best possible product. And you can see some pictures there just to give you a feel of what they look like when they're cracked out of the mold. So what makes the best casting? We want no dissolved gases in the molten metal, and there are techniques we can use for that. We want no shrinkage. Alan Hughes has told me many times that he used to imagine that the lack of adequate feeding made a sort of more homogeneous thing that just worked. We weren't quite sure. But actually, if you're trying to create a casting that has got no voids in it, then you need to cast it in an orientation and feed it with liquid metal in a way that leaves no voids that would otherwise appear through shrinkage. We want no insoluble particulates. Very easy to get stuff that's ceramics and bits and pieces mixed with the metal stream. We want no oxide films. So this comes back to having a pouring technique that keeps the metal in a nice, gentle flowing stream and not all churned up in a turbulent manner as you fill the mold cavity. We want no contaminants in the alloy, particularly lead and aluminium are disastrous, even in very small quantities, because they damage the grain boundaries and the properties of the metal to ring. We need a very precise control of the chemical composition, because we do want to get the optimum and brightest note at the same time as not making the bell brittle. So we do vary it. We have a little less tin in ones that are very big and a little more tin in ones that are small, but it's all closely controlled. Quiescent filling I've spoken about. And then the other thing today, which we have at our disposal, is a digital solidification modeling. And that's something which Westlers have been at the forefront of since computers became powerful enough to enable us to model some of the flowing and as to how to fill the mold. So how do we get this control? We use electric melting. every bit of metal that goes into our bells is melted through an electric induction furnaces, which gives us great control over temperatures. We can use nitrogen purging to get the gas content, and we use spectrometry. Again, modern computing power has made spectrometers so good that within a space of a few seconds almost from taking a sample, we can have a composition and we can adjust it and get it all exactly right. And then the running and feeding systems, as they are optimized by computer simulation. And that's exactly what we do. Professor Campbell, who actually he used to be, he's retired now, but he was on our board for many years. He was head of casting department at Birmingham University. And it was he and a chap called Mark Jolly, who's now at Cranfield, who developed many of these early software programs to practice optimizing how you fill a mold. They were sponsored by Jaguar Cars and Westleys, and a lot of the data that we needed for copper-based alloys, we developed between us for just that purpose. The experience in producing works of art and molding skills in particular, they definitely are part of our portfolio. It's not all technical, a lot of it is about individual skills and knowledge. So that's part of it. And then the materials selection and what we do that we also can test. And then the sand system these days, we don't use anything that's got moisture in it. They're sort of polymer type binders on sands, which we optimize to give the permeability and the venting that we need to make sure that there's no blows or sort of folds in the metal that would be very damaging. And then the pattern equipment, and this is where we again are very engaged with computer-aided designs. We actually make the pattern equipment and use the 3D modeling and so on, so the patterns can be as accurate as possible. So the metallurgy, and I don't want to go too technical here, but Coppertone alloys are especially interesting because they have peculiar characteristics when you get the tin content to a very high level. Lower levels of tin, which is what most of our bearing alloys is and where most of my experience has been in the past, they have a very good lubricity, as we call it, very slippery, so that's what makes them into really good bearings. But when you go beyond up to beyond into 20% of tin, you're making an alloy that is extremely hard. And the little diagram on the side there is called a phase diagram. And I don't blind you with science, but these tin alloys are strange because the crystalline structure of copper is a face center cubic, we call it, which is like the crystal alignment of it. And tin is a tetragonal crystal structure. So when the two things get mixed together, they have to accommodate each other by forming discrete phases, the eutectoids. So they make and this is what's strange about copper and tin. There's so many of them. You've got Cu10 SN3, you've got Cu6 SN5, Cu3 SN, Cu41 SN11. These are all ratios of copper and tin which form discrete phases and eutectoids and eutectics. And why that's important is because they don't marry up perfectly across the crystal structure. They all bash into each other at the grain boundaries. And what that does between the grain boundaries is that it locks it all up solid. And that means that the material has very little damping capacity. And damping capacity is the ability of a metal to absorb vibration and things. And so a car engine, for an example, is routinely made out of cast iron, the cylinder block, for the very reason that that cast iron with its graphite mixed with it is very good at absorbing vibrations and things. We want exactly the opposite in a bell. We want virtually zero damping capacity. And that is a characteristic which is delivered by this unique metallurgy. So, as I said earlier, I was trained as a metallurgist. That's my background. And it's been quite fascinating to learn a bit more about this within the company, really, and to see what can be done and what's been done already to right. So the effect of defects in castings is pretty bad, and we're just making little notes here to as an aid memo. The nucleation sites, anything that's a defect that's contained within the metal, is effectively a nucleation site. So when the bell is vibrating away and gets hit and so on, if there is any defect embedded in there, that would be a starting point for something bad to happen, for a crack to originate from. And so the way to avoid that is to eliminate these nucleates by getting very clean metal. And we've been over that now as to how we achieve that. And it's interesting, very briefly, so that people have an understanding of how the difference that clean metal makes. Talk as an example, I'll show you what's happened with steel alloys. The highest quality steel alloys now that would go into the crankshafts of a petrol engine or the main shaft that runs through a modern jet engine, they will melt that metal 3 times over under vacuum to extract all these things that I'm saying are difficult and dangerous. And the difference that makes to the fatigue life of those components is not a little bit better, it's enormous. You can put a shaft through a jet engine now, which will last the entire life of the jet engine. And similarly, you know, when did you last have a broken crankshaft or a broken camshaft in your motor car? It doesn't happen. And it's all about the metallurgy and clean metal. So that's something which I want to stress. We obviously can't afford to cast time in some of our cast parts that we make, because it gives an inert atmosphere and prohibits oxidation when the metal is in its liquid form. So now I want to move a little bit to what I've described as some rumours and untruths, just so we can talk about it. It is not true that bells deteriorate over time. A properly designed bell will, when struck with an appropriate clapper, be working well with inside its elastic limits, and the stress levels should be so little that they will not induce fatigue or any failure. And you know, that's exemplified by good bells that are still being used after many hundreds of years of service. So that's the good news about making something in metal. It does not deteriorate if the original cast product has got the integrity that it should have. So they are massively over-designed as a product, and the idea is that they should not absorb the energy from the strike, but rather let it keep reverberating round. And it's very fascinating how long a bell, which you know better than me probably, will continue to sound after you've struck it. So weight is not an issue in bells like it is with other of our more highly engineered products. And the most important thing is simply to make it a high integrity, clean cast part. The correct shaped bell will make the right note within reason, and obviously after that it becomes tuned, and again with modern machinery for electronic tuning, that can be done to a level that wasn't possible in the past. So modern bells are probably better tuned than ever. And so now I'll move to what I've described as some facts. That horsehair and muck sands, which were the traditional way of making a mold for a bell, were okay 100 years ago. But we honestly believe that it's so much cleverer to use all modern technologies just to make something which is in a different class. So that's what we do. The skilled people that we've got and what we've learned over the last few years, because we started making bells, I'm trying to think, first ones we made probably in 2018. I can't remember exactly how many, but we've made well over 100 sort of tower bells in between times, probably more than that, but I haven't added them up precisely. So now we move to, this is one of our most recent projects, just to show you. On the left side, that's the bell tower at Ledbury in Worcestershire. And that's a bell which we made quite recently it's a remembrance bell to celebrate 100 years since the end of the First World War. And just to give you a feel of what can be done. And with these poppies were all created by using 3D CAD modeling for the pattern equipment. We have on the go at the moment quite a few things which are being quoted for and debated. I don't know whether some of you may or may not be familiar with these places, Great Chisel and HMS Alfred, which I think is now an order. These are all current bells that we're working with and aiming to get. I would like to say thank you to Nigel Taylor, who I think may be on this call, because he's been very helpful towards us throughout the whole process. Nigel was the main man at Whitechapel Bell Foundry for a long time and worked with Whites of Appleton as well, who we work in conjunction with because they tune the bells on their site and hang them. We just focus on getting the patterns and the castings of the optimum quality and then passing them on to Whites of Appleton and Nigel to complete the job. Terry King, who's a wonderful foundryman, who's my founder director up at Newcastle under Lyme, has been particularly valuable in all his efforts to work out the systems and methods that we have to optimize production. So it's fascinating that, in my opinion, the tower bells obviously highly valued by the community and the bell ringing community, but I think bells and clocks in general have often formed the centerpiece of human communities located all over the UK in towns and city centres and from medieval times across the whole of Europe. So I find it fascinating to see how we might be able to bring some of this back to life again, to the extent that we can promote the fact that you can get, much bigger and better bells than ever. And let's see if we can excite people to try and design some pieces that are not necessarily just to be used in churches. It's quite interesting as well, because when you try and look at the marketing of bells, we find that each of the different countries and continents have their own traditions and alliances and allegiances. So it's quite a British thing. I mean, Whitechapel Bells in particular is a very British situation, and we stick to our own patches largely, even though we do have international competitors for some of these things. So we intend to respect all these traditions and maintain the Britishness of our bells. But we, as said a minute ago, we would like to try and fire up the imagination of some of our architects and town planners to see if we can get them excited about using bells more than they do. So that's really, at this point, as much as I was going to say. I hope you've enjoyed what I've just been on about, and I very much welcome any questions or queries. I'll be delighted to try and answer them. So I'll shut up now and I'll take my screen off, and then you can talk to me directly. Thank you.
Great. Thank you for that, Tom. That was fascinating, and we'll do some more formal thank yous a bit later. But thank you for that. And I grew up really close to Tilehurst. I remember ringing on them when I was a youngster. So I'm looking forward to going back in a year's time or so when that project's finished and having another ring there. We've got a number of questions that have come in, and but I want to start with a question about the Wesley Award, because you sponsored the Wesley Award for church maintenance through the Central Council, and actually we had last year's winner, Sue McLaren, came to speak to us a couple of months back. I wonder what motivated you to sort of donate that award and the money that goes with it to the Central Council. I just wondered how you got involved in that project.
Well, it was simply to try and encourage younger bell ringers and to keep the bell ringing community supported to a level that there's something to aspire to, and of course from our own selfish perspective to bring our name in front of you guys who are ringing the bells, because we do recognize that. I'm sure you all recognize Whitechapel, but I think Westley Group sort of hides behind that, and I want to be transparent. We're not trying to hide behind it. We want you to understand that what we're using Whitechapel's designs, but we're using 21st century techniques, which comes from the Westley Group, to make this combination, which I hope gives the best answer. And that's where Whites of Appleton as well have been brilliant, because we recognise that we're not expert at hanging the bells and all that stuff, but as a team effort, it works extremely well. And to spread that word amongst you enthusiastic ringers and people who've done a good job and sorting towers is just our ambition to do that, and it's been. I hope it's been helpful, and we've met some nice people along the way. So it's good as far as I'm
On behalf of
concerned.
the ringing community, I will thank you for your generous award as well. A couple of questions then. So some engineering questions have come in. So first of all, could bells be cast centrifugally?
No, not really, because the external, well, there's two reasons why not. One, the external markings on the bell, the embellishments and things go on there, need to be in a material that wouldn't tolerate the forces involved in the centrifugal casting technique. And the other issue with centrifugal casting is that it has to be hollow, and because that's how the way it works. It flings everything to while it's molten, it flings everything to the outside of the mold. Excuse me. And therefore, and the top of a bell, as you know, is not hollow. It has to be connected to make the whole thing work. As a matter of interest, because it's an interesting question, and you may find this fascinating, modern jet engines, the external part of the engine that contains all the moving turbine blades is a centrifugal casting with some quite profound detailing on the outside where all the hydraulic systems go through and so on. And the reason they do that is because they want the integrity of the cast part to be enormous, because if the engine breaks up through a bird strike or a failure of blades, it contains the blades within the engine, so they drop out the back of the engine and don't puncture the fuselage. So that's how good centrifugal casting is, but it costs an awful lot of money to make those. We had to do it in ceramic, to make the ceramic external parts that the engine's built back from. Yeah.
Oh, thank you. You used a phrase around sort of when a bell was struck with an appropriate clapper. And someone has just asked a question about this. Beyond just not causing fatigue, can you tell us anything about the material science of clappers? And extension question, what do you think about the experiments of wooden shafted clappers?
I confess I am not an expert on clapper design. You should speak to Nigel and others who have got more experience than me. But what I can tell you is that our bells, because they are very dense, and that's generally acknowledged now, we made a whole set for Linfield not that long ago, and they were absolutely delighted with the sound from the bells. And they did sound really relatively bright, if I can say that. And I don't know, others will tell you better than me, by adjustments with the clappers, they got something which was absolutely spot on. And you can't make a bell that's a bit dull come bright, but you can make a bell that's too bright, the right level of sound, by adjusting the clapper. So the clapper is a crucial part of getting the setup right. And I would simply hand you over to Brian Weiss about it, and that is some of the people who know a great deal more about it than me. But I'm sure we could help to optimize the clapper to go with the bell. But the answer is the amount of the clappers are so light relative to the size of the bell. The amount of energy you transfer to the bell is very modest indeed, and it will never damage a bell. Bells that crack were cracked almost from the beginning in most cases. Yeah.
Oh, thank you. If you encountered a bell for which you did not have a pattern for, but which you wanted to replicate, would it be possible to sort of scan it in some way? And replicate it. For example, in theory, could we replicate, the bells of York or Westminster Abbey or whatever?
Yeah. That is absolutely correct, and that's exactly what we do. And we made a bell recently for Worcester Cathedral, which was an augmentation to their thing, and we purposely copied a tailored design with their permission. And you can literally, with modern CAD techniques, you can make anything, and you can do it all digitally for very modest money, and then create a perfect pattern to make it from. And of course, the other thing that in the olden days they used timber and whatever, but now you can use these plastic materials that the 3D machining centers and 5-axis and all this clever stuff that goes on the material that you carve it from is very stable, both dimensionally and strong, so you can put your sands on it, so you don't get distortion. Or it is the science is evolving fast, and it's a really good way to make anything really well. And that's because a lot of this crosses over, I was saying earlier, with what we do in the artwork world as well.
Oh, super. There's lots of questions coming in, lots of engagement. So I will keep pushing you until you tell me that you're fed up.
Right.
Are there design elements to account for expected environmental temperatures and temperature fluctuations at the site of use, just to be sort of mindful of the environment in which the bell has been cast when you're?
Yeah, I mean, our own foundry environment is cleaner and better than ever. The temperatures. Are we referring to where the bells are being hung? Is it rather than because I would suggest that bronze is such a stable material. The environment in which it's hung is not an issue. I mean, anything in the UK or even abroad. I mean, the bells work all over the world in high temperatures, low temperatures. They just work, and the frequency is what it is because that is a characteristic of the shape and the density of the material. So yeah, it's not a problem where they're hung. Yeah.
Super. And Andrew asks, can the production cost of a new bell be compared with that of the old method of production? You talked a little bit about sort of the change in methods of production. Can we compare easily?
Yeah, I mean, the old method of doing it had a low cost of materials to create the mold, but a high cost of labor to create the mold, and we're the reverse. We have a high cost of the patterns and the preparation for the mold, and we can make the mold in a shorter time. So there's a sort of balance going on there between costs, and you can't actually say what's going to be the most expensive, but we just stick to our music of making the best by a technique in terms of molds and that we know is going to work. Yeah.
Super. Tom, you've got lots of praise coming in, and I'll just read this from John Anderson, who is a harsh critic. I mean that in a polite way, John. I know John well. I must have heard dozens of bells around, sort of, and their manufacture. As an engineer, this is the most enlightening talk. Thank you, Tom. So, but lots of praise coming in. But as I say, I know John well, and he wouldn't say that if he didn't mean it. So, thank you.
That's very kind. Thank you. I appreciate it.
So Alison has asked a question. Have you done any analysis of older bells to compare their I'm going to still say this, metallographic properties with which you now produce? I hope I said that right.
The answer is we have done some, but not enough. And I don't know how many of you are familiar with a bit of a wrangle that's going on at the moment for what might become of the old Whitechapel Bell Foundry site. But the proposition there is that we would continue some level of casting in a small model foundry to sort of demonstrate the process, but also to have a research centre there, because much of Whitechapel's records, as I said earlier, have been put into the Museum of London, and again you can scan those and bring them out of there so we can share them with people. And Alison's point about checking and testing some older bells and purposely going on a mission to get some proper interesting data from the past is something which I would like to do. The answer to the question is we haven't done enough of it yet, but we would like to do a great deal more. And I'd also like to, and this is I've discussed this with others as well, to experiment to see about different shapes, because there are a lot of interesting shapes, not in the UK, but around the world, that have all sorts of distinctive and interesting characteristics. And I'd be interested to explore that, because we're sticking to our core competence of being a good foundry, and we're not wedded to a particular shape as some people are. And so I think that's a very interesting area to explore, and I'll be happy to share the results from going with Alison and anyone else. Yeah.
A research centre sounds excellent.
Well, that's what we'd like to do, and we'd like to do it with young people from that part of London that could engage with us. That's part of what we're trying to plan. But there is, people may know, there's ongoing planning things at the moment, which hasn't brought it to a conclusion. But my hope is that we'll know relatively soon what is going to be possible on that site. Yeah.
Super. Susan asks, how many bells has the Westley Group cast in total?
I think over 100 now, tower bells. I did want to be able to tell you that tonight, but Terry, a chap I was telling you about, he's on holiday in Cornwall at the moment, so I couldn't get hold of him to a precise number, but it's at least 100. Yeah, tower bells. Yeah.
Thank you. Andrew asks, how fast does a casting centrifuge spin, and how many G?
That's a good question. Well, we have molds of different diameters. So the bigger the diameter, the faster the perimeter spins. We can, so I'd say minimum 50 to 100 revs, sometimes up to 250 to 300 revs per minute as the rotational speed. And we adjust the speed to try and bring the G forces to something between 5 and 10 G. Sometimes it can be more, but you've got to be careful because there's an awful lot of energy when you've got a few tons of metal spinning round at that sort of rate. If you do the physics, it's an incredible amount of energy. So it is a dangerous thing to put too much G on it, but short, between 5 and 10 G, and between 100 revs up to maybe 500, yeah.
Super. I'll ask just a couple more questions, Tom, and then I promise I'll let you have a short breather whilst I sort of talk about a couple of other things. Just perhaps two more questions. Can you let us know how the inner surface of the bell is machined?
We just use a vertical boring machine, which is like a lathe turned on its end. And we've, because of our other engineering practices, we've got vertical boring machines that can turn, more than 6 feet in diameter down to ones for the smallest of bells. But Coppertone have tuning equipment which was salvaged from Whitechapel, which they've installed in their premises, and Nigel and their employees are capable of tuning bells on the premises there as well as elsewhere. Yeah.
And an interesting sort of philosophical question: with the casting precision, is it possible, do you think, to make a bell that does not need fine tuning?
Yes, it is possible, but I think it's safer to make one that's known to be slightly oversized so that you can trim it more accurately. It becomes, it's not impossible, but it becomes more difficult, and you make a trap for yourself if you get it wrong, because you can't. You've got to make the bell all over again. There's no escape route if it's not the right thing. So we tend to make them marginally larger where they need to be, and then trim them by this fine machining. That's a much safer route to getting the end product. Yeah.
Super. Tom, I'll let you have a breather. There are a couple, there's lots of thanks coming in the chat box, so please have a look in the chat box if you get a chance. There are a couple more sort of questions and comments, but perhaps we'll have a look at some of those if we have time a little bit later. Just a couple of things from me. First of all, I'm going to mark it next week. In fact, this is timed to perfection, actually, because next week we have Chris Pickford come to talk to us about the history of Birmingham's bell foundries, which links in really well with your talk, Tom. It's almost like we did it by design. I think it's probably more by luck, but anyway. So if anyone would like to come along to that, you'll be very welcome. Email smgcbr@gmail.com if you're not a member, don't usually receive our emails, and you'll be very welcome to join that talk. I should also have said at the start that actually enormous credit needs to go to Alison Hodge for organising tonight's talk. I mean, Alison approached me a while back now to ask for some talks between the Central Council and the St Martin's Guild, and of course I was delighted to accept. And actually, it's Alison who's organised tonight, so a huge thank you to Alison for that as well. As I say, lots of thanks coming into the chat box. So I'm going to formally end the talk in just a moment, but if people want to stay around and sort of ask any more questions, or sort of have an informal chat, I'm sure we can have sort of 5 minutes or so for that if you've still got a puff left to do so. As I say, lots of thanks coming in. But Tom, I think tonight's talk's been absolutely fascinating. I think you can see by the level of engagement that ringers have held with you that actually there is a level of interest there between the work that you're doing and the ringing community. And I think often us as ringers, we don't have enough of a knowledge actually of what goes on above our heads when we're ringing. So it's wonderful tonight to have you to sort of help uncover some of the mysteries behind sort of the mechanics of our craft and our art. So thank you for that. Thank you for continued support with the Wesley Award, and thank you for joining us tonight.
Yeah, thank you for inviting me. It's been a pleasure, and you can send me the link to the Birmingham Foundries lecture. I'd be interested to learn a little more about that myself.
You'd be very welcome.
Yeah, thank you for everyone. Thank you for your attention, and hopefully we'll keep in touch. Yeah.